We're going to cover some very basic material on solutions and solubility. In terms of structure, like dissolves like. What this means is that polar molecules will dissolve in polar solvents and nonpolar molecules will dissolve in nonpolar solvents. In order to be soluble in water, molecules need to be polar like water. The center molecule with the green center, BH3, would not be soluble in water because, based on its structure, it is nonpolar. The molecule to the right of that, CH3COOH, would be soluble in water because its structure is polar. In order to be soluble in nonpolar solvents, like benzene on the left, the molecule must also be nonpolar. Again, the center molecule with the green center, BF3, would certainly be soluble in the benzene, while the acetic acid to the right would not be soluble. Like dissolves like explains why oil and water do not mix. Oil is a long, nonpolar molecule. Water is polar, so they simply layer themselves. The reason that the oil floats on top is because of its low density, but the reason they don't mix is because of their difference in structure. A solution is a stable homogeneous mixture that is mixed molecule by molecule. In the solution, the solvent is the substance that does the dissolving. It is present in the larger amount. The solute is the substance that is dissolved. It is usually present in the smaller amount. Aqueous solutions are solutions with water as the solvent. Water is an excellent solvent for polar substances because it is also a polar substance. Since many substances that are dissolved are polar, water is often called the universal solvent. Hydration is the process of breaking the ions of salts apart and then surrounding them with water molecules. Water molecules come in, they orient themselves with their polar, positive and negative ends around the ions, and then surround the ions. In hydration, the polar water molecules interact with the positive and negative ions of a salt, assisting in the dissociation process. Soluble is the term we use to mean able to dissolve in a solvent. Insoluble means unable to dissolve in a solvent. We use these terms usually when we're talking about a solid solute and a liquid solvent, like salt and water. Miscible is a term we use when we talk about two liquids that can dissolve in each other, like alcohol and water. Immiscible means two liquids that cannot dissolve in each other, like oil and water. Solubility is the maximum amount of substance that will dissolve at any given temperature. Usually when you increase the temperature, you will increase the solubility of a substance. This solubility graph shows the dependence of solubility on temperature. For some substances, heating them up will certainly increase the amount that dissolves. For other substances, heating them up has very little effect, and for a few substances, you actually decrease their solubility upon heating them. You can see this green substance with its steep slope certainly increases its solubility upon being heated. A lot more of the substance will dissolve at higher temperatures. The substance represented by this pink line has very little change in its solubility as temperature is increased. The substance represented by this line actually decreases in solubility as temperature is increased. This is rare for a solid, but very common for a gas. As temperature increases, the solubility of a gas actually decreases. Gases are more soluble in cold solutions. This is due to the fact that gas molecules are less dense than the surrounding liquid molecules. By keeping them cold, you slow their motion down, you increase the density of the gas, and more of the gas will stay dissolved in the liquid. This is why cold soft drinks will keep more of their fizz than the hot soft drink. More oxygen will be dissolved in cold water than in hot water. So for goldfish in a bowl, the temperature of their water needs to remain fairly cool to allow enough dissolved oxygen. Saturated solutions contain the maximum amount of solute that can be dissolved. If you add more, it will settle to the bottom. Unsaturated solutions can dissolve more solvent. If you add more, it will continue to dissolve. Supersaturated solutions are solutions that are temporarily holding more solute than they normally can. And if you place a seed crystal in them, you will get an immediate precipitation of crystals. If you add a solid to an unsaturated solution, it will dissolve. If you add a solid to a saturated solution, the solvent cannot dissolve anymore, so the solute will settle out to the bottom. If you add a solid to a supersaturated solution, you will get an immediate crystallization throughout the entire solution. Electrolytes are solutions that conduct electricity. Electrolytes contain ions that are charged particles that dissociate and move through the solution to conduct electricity. Electricity is nothing more than moving ions through the solution. These electrolyte solutions are classified in 3 different ways. Strong electrolytes dissociate 100% and conduct electricity to a large degree. Weak electrolytes dissociate only a small percentage but still conduct electricity. Non-electrolytes are not ionic compounds, do not form ions, and do not conduct electricity.